All right, howdy. This is Team 6. My name's Carly Frankowiak, and I'm joined today by Zach Bankston, Michelle Grauman, and Austin Ross. And our group will be discussing our elderberry processing plant project. So for today's meeting, our agenda will include a brief project overview, including project background, the constraints that we considered, standards and regulations that were considered, as well as a flow analysis of how our process flows, a decision matrix that led us to our recommended solution, as well as an economic analysis and risk analysis and implementation plan of our final solution. So for our project overview, our group was tasked with the development of an elderberry processing system based in Guatemala. It's the first of its kind in the country for a value-added elderberry product. The elderberry crop is currently exported. It's a pretty popular crop in the country, and so by creating a value-added product, it will benefit the local economy by giving producers an additional way to market their product and just give more jobs and such into the local economy. The value-added product we are making specifically is a concentrate that will be sold to be further developed into a immune support supplement, which is why the crop is so popular as far as antioxidant benefits. A part of our project was also finding a way to utilize the byproduct and make it into a useful product as well. As far as the project background, the elderberry elderberry crop itself is very temperature sensitive, and this was a large factor in choosing our various solutions. And so the reason it's temperature sensitive is because of the antioxidant properties that the plant has. And so if the plant is heated too excessively, the antioxidant properties are damaged and it kind of loses its effectiveness. At the same time, the plant also has toxic properties, and the leaves, stems, and unripe berries can contain levels of cyanide that would be certainly harmful to consume. And so part of our process that we'll discuss later, we'll talk about how we're mitigating that risk while still maximizing the benefits of the antioxidants. Our supply is based off of 100 pounds a day of elderberries flowing through our system. Initially, we were told that to expect anywhere between 100 to 1,000 pounds, but we focused on 100 pounds a day coming through the system, which will make a certain amount of concentrate, which will be discussed later as well. It was important for this system to be modular and for it to be able to grow in the future by either hiring additional workers or increasing machinery or shifts or something like that. Another factor was that there was wood available from local forests, and the client emphasized this as a heat source. And so that was also taken into account when selecting our final solution. Some constraints that were considered in developing our project was that we had limited information. Like I mentioned, this was the first value-added product in the country, and so market research was a bit limited in finding what we could price our product at and kind of how it's sold and exported currently, because it doesn't exist currently. And so a lot of our information was based off of similar products in the US, but those prices will definitely vary because of the fact that Guatemala is a developing country. Like I said, the physical properties, the elderberry is very temperature sensitive and has a short shelf life and can only be, left out for, maybe a day at a time. And so it's very important that it be frozen either before processing and after the concentrate is made. Our budget was also a constraint that was considered, since this is the first the first time this is being done, especially in the area. It's important that we were working with a limited budget. We did not have exact numbers, but we wanted to make it as cost effective for the client as possible. And so it was very convenient that the client had an available existing building. So renovations or building acquisition was not something that we had to worry about. And so that helps our budget greatly. Another factor was electricity. The cost of electricity was a big thing, and so we made sure that each of our machines were able to, work with that. and electricity was also only available in single phase. And so each of the pieces of equipment we chose were sure to follow that requirement. As far as standards and regulations, when we did our initial literature review, we referenced the Central American Secretariat of Economic Integration, as well as occupational and safety health legislation. And these kind of helped point us towards things we should consider as far as food safety and worker safety. And those risks will be discussed later as well. But these sources just kind of helped us point us towards what we needed to consider as in that regard. I'm now going to pass it over to Michelle to go over a brief flow analysis.
So on our flow analysis chart, you can see a general overview of what's going into and out of our system. We're going to be receiving berries from the harvesting field in bushels, and they'll need to be washed and frozen. They need to have a process that removes their stems and be frozen. Unripe berries need to be removed because of toxic contents. The berries need to be juiced, and then we need to remove the water so that we can create the concentrate. And then we need to find something to do with the byproduct. So as you can see, our inputs include berries, water, and then cleaning solutions for the water bath. And then outputs include the byproduct, the concentrate, and the wastewater. So our potential solutions that we were looking into were vacuum distillation, freeze drying, and direct heat. Vacuum distillation is our first solution, where you separate liquids with a reduced boiling point. This has been used in other instances, including areas where excess heat would cause damage to the product. In freeze drying, the second solution, juice is frozen, water is extracted as vapor, and then a slow rise in temperature removes the leftover moisture. Then in the third solution that we suggested was direct heat. And in this process, you could use basic heat exchangers or large batches of tubs, which could be used with wood burning fuel. It's kind of a basic system, but you could still get the effects. Next slide. And so when we were creating our decision analysis, we created some criteria such as efficiency, cost, resource sustainability, and capacity and speed. We created a rating scale that rated the criteria from 1 to 10. So here you can see our decision matrix. Solution 1 was the vacuum distillation system, scoring 7.1. Solution 2 was the freeze drying system, scoring 6.3. And then solution 3 was the heat system, scoring 7.05. And then to get into this, efficiency was the preservation of nutrients and how well that the preservation of the berries was collected. So we weighted this 40%. The high score in this section was freeze drying with a score of 9 because freeze drying has a 97% nutrient preservation rate. And then the low score was the heating system because in the 5 to 10 minute boils, there is a 10% loss of antioxidants. Next was cost with a weight of 30%. As mentioned before, it's important that we kept the budget as low as possible. So in this section, heat was the highest scoring because of its relative simple nature, and the low score was freeze drying because of the expensive equipment. In the next section, which was resource sustainability, which was availability of nearby resources and obtainment of equipment, it had a weight of 15%. And the high score was heat because you could use the wood resources, and then freeze drying scored 5 because the equipment is harder to obtain. Next slide. Oh, capacity and speed, sorry. Capacity and speed scored a weight of 15% because of how quick the process could be. And so the high score was the vacuum distillation process with a score of 8 because it's a quicker heating process than the other solutions. And the low score was the freeze drying process because you have to slowly raise and lower the temperatures. So some qualitative factors that we had to include was labor availability and user availability. Labor availability included adult workers, and then usability was skilled versus unskilled workers. In Guatemala, it's more common to find unskilled workers, so we had to implement that in the other in the implementation plan. Next, I'll be passing it on to Zach to do the recommended solution.
There we go. So our final solution begins with the berries coming into the system as they would have been harvested from the field. They come in on bushels, as you can see in my background. The first step that they go through is a water bath. They are put in these perforated containers and then submerged into a pool of water. Submerging them will help remove contaminants from the field and clean off any foreign matter such as fertilizer that still may remain on the berries. Once they're done in the water bath, they're going to be drip dried and then moved on to a freezer. If you can move on to the next slide, please. So the freezing process, they're going to be laid out on trays, kind of spread out in single layers. The single layers will help them prevent from freezing together in large clumps. That way, when we go to remove the stems later on, it'll be easier to shake them loose individually. They'll freeze for about 2 to 3 hours at 32 degrees Fahrenheit. This is one of the longest processes out of the whole system, which is why it's beneficial that we can do multiple trays at a time. Some of these images are misleading. The freezer actually has a larger capacity than the image leads on to believe. Next slide, please. So once they're frozen, the reason we freeze them is it extends the shelf life and hardens the exterior of the berries. Hardening the exterior helps with the process of destemming. How we chose to destem the berries is using a mechanical shaker system. The mechanical shaker basically shakes the berries hard enough to fall from the stems, and they'll be delivered. There you go. They'll be delivered through the bottom of the chute at the bottom. The stems and the leaves will remain in the top of the shaker and can be discarded of afterwards. Here we have two options. If there's still berries being processed further down the line and we're not ready for these berries to be processed, they can return to the freezer and be stored there until they're needed for later on, or they can continue down the line to the second water bath. Next slide, please. So the second water bath is very similar to the first. They're put in a perforated container, submerged in water. This one, however, has a little bit more important purpose than the first one does. This one allows us to not only thaw the berries from the freezing process, but it allows us to get rid of unripe berries, since the unripe berries will actually float to the surface of the water while they're submerged. So the workers will bring them in the perforated containers, submerge them to the bottom, and then kind of jostle the container to make sure that none of the berries are stuck under possibly ripe berries. They'll do that for a few minutes to ensure that all of the unripe berries have floated to the surface, and we'll use just a skimmer to skim the unripe berries off the surface, and those unripe berries will also be discarded of. Once they're thawed and all the unripe berries have been removed, we move on to the juicing process. So the juicing process uses a steam juicer. This process will take about half an hour, and the steam juicer will be heated to about 185 degrees Fahrenheit. One thing that this helps with is it doesn't bring it to a boiling temperature, so those antioxidants are still going to remain in the berries, but it does remove any remaining toxins that may still be in the berries. As we mentioned before, our client has requested that we use some of the natural wood around the facility, so we've been able to incorporate a wood-fired steam juicer. This one uses just a simple fire underneath it. And once the juice has been extracted from the berries, we're left with a bagasse byproduct in the juicer. Next slide, please. The bagasse we decided to dry out and sell to local bakeries and restaurants. This can be used as a garnish or addition to food products. Our clients informed us that there are several restaurants in the area that several restaurants in the area that bake pastries and make things such as the Danish you can see in the picture below. And this will be a secondary source of revenue for this whole system. Next slide. So once the juice is extracted from the berries, we decided to go with the vacuum distillation system. This particular vacuum distiller can remove 1/3 of an ounce of water per minute, and its evaporating flask has a total volume of 1.3 gallons. However, that will not necessarily always be full. This one, the rates can change per how much juice we have at the moment, which is why I left just the water per minute and not how long this particular step will take, because that'll vary with whatever our production is throughout the day. The advantage of this vacuum distiller is it reduces the boiling point to 122 degrees Fahrenheit. So that way we're not actually heating the solution much more than, I want to say that's equivalent to 50 degrees Celsius. So less than half the boiling point, or sorry, exactly half the boiling point of water. So this will help remove the water from the solution without damaging any of the antioxidants. And then next slide. So the last part of our system is packaging. Our client requested that it be packaged in buckets. We chose a 1-gallon container as it's more modular in a sense. We expect to produce just over 1 gallon of concentrate a day with our estimated 100 pounds of berries. We chose the low end to represent our system. That way, like I mentioned with the vacuum distiller, it won't be full when we're producing. So the components of our system can still be filled more. However, we wanted to make sure that we weren't overdoing our equipment. So using the low end, we were able to meet all the requirements for just 100 pounds a day instead of not being able to meet the requirements of 1,000 pounds a day. So this 1-gallon container is easily stacked and stored. It's watertight, and once it is filled, it will be marked the date that it was filled, and it will be stored back in the freezer for later selling. And now I'll pass it on to Austin for, I believe, the economic analysis.
Yeah, so I'm going to briefly run through some of the economics for our project. To start out with, all of our numbers are going to be in USD. In Guatemala, they use the quetzal, and the exchange rate between USD and quetzal, $1 equals 7.73 quetzals. Most of the equipment that we are looking at purchasing is from the US, but things like labor cost will actually be in quetzal. So for this table, this includes all of the equipment necessary for our operation. Our system uses a relatively small amount of equipment, and most of the equipment that we're using is pretty cheap and simple, with an exception for the vacuum distiller and the freezer. So the most expensive pieces of equipment we have is the vacuum distiller, which is the centerpiece of our entire operation. Which is right at over $4,000, but that puts our total fixed cost for the system at just under $7,000. Next slide. So the first table shows the variable cost for our system. As mentioned, we're using 1-gallon buckets for containing the concentrate. For our electricity costs, we use the average electricity cost for Guatemala, which is about 16 cents per kilowatt hour. Our cost for water is $0 because there's a well on site, and so the cost for the water was absorbed by the electricity costs, as all we're doing is running a pump. For the cost of labor, we're planning on paying 4 line workers the Guatemalan minimum wage of $1.46, and we plan to pay our floor manager $5.54 per hour, which puts us at a total cost of $140 in labor per day. So something that's important to note for selling the concentrate and berry pulp, because the operation will be the first of its kind in Guatemala, we can't get an exact price for the elderberry products actually in Guatemala. So we found a wide range of prices for concentrate and pulp, so we did our best to make a conservative average, which we plan on selling a concentrate for $57 a gallon and the berry pulp for $5 per pound. So with those prices, the operation will generate $180 a day, assuming we process the minimum of 100 pounds of elderberries per day. And again, assuming we're selling the concentrate for $57 a gallon and the pulp for $5 per pound, our operation will make $25 a day in profit. And so we're looking at just under 13 months for our payback period. Something that's important to note, we're only making $25 a day selling the concentrate and berry pulp. So we don't have a ton of room in terms of lowering the price of the concentrate or the pulp. We have a little bit of wiggle room, but not much. But I'll talk about that more in risk analysis. But we are at risk of losing money if we lower the price too far. So speaking of risks, there's two risks that we plan to mitigate. The first being the risk of the product not making money, as just mentioned. And the second risk is the safety of our employees and the safety of the actual product. So as mentioned, this is the first elderberry processing facility in Guatemala, and there's no established market for the elderberry concentrate and pulp. So because of this, we're not certain that we'll be able to sell our product at the desired price. Next slide. So to give the operation the best chance of success in turning a profit, we did our best to design our system to be scalable and economically as efficient as possible. Our fixed costs for our operations are about as low as we're able to get them, as all of our equipment is completely necessary. But we may be able to reduce the variable costs of our operations by hiring less workers if demand dictates that. Next slide. So the second type of risk we took steps to mitigate concerns overall safety. So to protect our employees and reduce chance of injury, all employees will receive proper training and will be supplied personal protective equipment. The second part of overall safety pertains specifically to the safety of our actual product. Because we're working with produce and there's a chance of contamination just from it being harvested and being outside, we'll need to take steps to make sure that all the berries are washed. In addition, the stems, leaves, and unripe berries are actually toxic and would make our product unsafe if they weren't dealt with. So to reduce the chance of contamination, the berries are washed twice and steam juiced, and the temperatures inside the steam juicers are high enough to kill any bacteria that's on the surface of the elderberries. But it is important that our berries are washed twice just to make sure they're completely clean before they're processed. To ensure that all toxins are removed from the elderberries, we plan on using an industrial destemming machine to make sure all the leaves and stems are removed. Can you go to the next slide? Thank you. To ensure that all the toxins are removed, we're using a destemmer. When the elderberries are submerged in the second water bath, a worker will sit there and disturb the mixture of berries and water to ensure that all the unripe berries are actually able to float to the top, so that all of those are removed so that we have no chance of any toxins remaining in our elderberries when they're juiced. Although we're not planning on using the vacuum distiller specifically for toxin removal, the distiller would still remove any toxins that were present in the juice should any toxin make it to that stage. So for our implementation plan, we broke it down into 4 simple steps. The first being the preparation of the building for our new equipment, the installation of our new equipment, the training of all of our employees, and the establishment of buyers for our actual product. Next. So fortunately, there's an existing building on site, so there's no new construction needed. The only thing that we'll need to do is ensure that all electricity and water lines are ran to the correct place to support our machinery, and we will need to completely clean and sanitize the building to a food safe level as we are making concentrate. For the installation of the equipment, we plan on using our new employees to install the machines, and they'll be arranged in a fashion that supports our operation in an efficient manner. So each employee will receive training for their designated piece of equipment. Employees will also receive training on hazards and government regulations. Employees will also receive training on the maintenance and upkeep of equipment in case something is to break and to maintain our equipment properly. So the final step in implementation is finding buyers for our concentrate and berry pulp. In addition to the selling of the products to any buyers that the client already has connections to, more buyers would be found to ensure that all of our product is sold so that we don't have any sitting left over. The amount of time needed, I'm sorry, next slide. So the amount of time needed for our entire project, assuming we had started on June 1st, the project would end on July 14th, which would be 35 days, including weekends. The longest period that we'll be waiting is 28 days, and it would likely be a shorter period than 28 days, but that would be shipping of the actual equipment to our facility. Other than that, everything else should take just 1 or 2 days. So that's it. That's what we got.
Okay, Dr. Castell, would you like to begin with questions and comments?
Yes, I really like your presentation. Very professional, very well developed, good flow, good distribution as a speaker. So I really appreciate the in-depth description of the unit operations. That was wonderful. Everything you say is correct. So that you did a very good job on learning all the different steps, right, required to make that concentrate. So again, good visuals, good distribution, speaker. The only thing that's missing to me is numbers. And I know I understand the difficulty of talking to your client and getting set numbers, and you are playing with 100 pounds to 1,000. And so I understand that. But if I would have seen you could have easily done a simple material balance where, if you start with 100 pounds of the fruits, you're going to have some losses in your steamer, in your separator, right? When you are separating in the freezing. So there are some losses of product. And then you have that huge step, which is the concentration unit operation, right? When you have a liquid with maybe 95% is water, and then you're concentrating that too. And my question was, what is the final concentration that you targeted for your product? What is the percent solids? And maybe this is in the report. I just don't see that in the presentation, right? If your client had been here, maybe he would have asked you, what is the percent solutes in this concentrate that you are designing your system for? Do you know?
We do have those numbers, but we did fail to put them in this presentation.
Okay, and I believe you do, yes. It's around 65%. I think that was your target, right? That's what I know from the engineering team. So I'm not sure if you follow the same target, because concentrates vary. So to me, that was missing, right? That's an important technical point, because that's a very energy intensive operation, right? You're removing water from a solution is very heat energy intensive, if you remember from 350. So that so I was curious, how long will it take, right? And you said it very well. You cannot give a specific because you still don't know how much you can process on that. So that what really was missing to me, right? Is I had to address those numbers on exactly. And one more thing, you are thawing the frozen berries. How long will that take? So you have a very good overall description of the different parts. Putting it together as a process, that's what is a little blurry to me. And maybe it is in the report, but it didn't come across in your presentation, because you will have one worker, right, in the steamer, collecting the frozen berries, putting them in the separation, water bath, moving that to the juicer, and then finally the vacuum distiller system and the packaging, right? So that, I was curious how long will it take if we're starting with 100 pounds of the berries. That's what I think is just the only thing that I could point that is missing in the overall assessment of your solution. So that again, that's what I need to see to have a good sense on how long will it take. And one more tiny question. You're saying that the concentrate is going to be stored frozen or chilled, because you wrote chilled refrigeration. So what is the actual storage condition for your concentrate?
Yes, ma'am. That was a matter of bad semantics on the slide, but it will be stored frozen.
Yeah, exactly. And yeah, okay. Because the shelf life is so low. Very good. So no, overall, excellent. I really pleased how the team, and I understand the difficulties communicating with the client, lack of certainty on what you're doing. You were able to put something together and provide, more importantly, good economic analysis of assumptions to the client that gives the client a starting point. If he wants to do that, here is something that he can use. So I think he benefits a lot from your work. So excellent team, excellent production, just those tiny numbers that I'm going to be looking for, that I know you have and you can calculate. So good job, excellent. So congratulations. Professor McGee, all
Yes.
yours.
Thank you, Dr. Castell. Yeah, I agree with all her comments. This was this is a model presentation. I mean, I'm going to take these slides and with a few tweaks that I'll mention here in a minute, use these as an example next year for this is what a presentation looks like that really hit on all cylinders. It's 25 minutes long, very evenly divided among the four of you. Carly, your description of the constraints were the best I've seen. I wish I could have written down everything you said, but you talked about how not only the constraints, but how it affected your solution, how you took those into account. Your description there was really top notch. Michelle, your presentation of the potential solutions was my favorite. I feel like the flow analysis went kind of quickly, and I'm going to ask you to review that here in a minute. But that's okay, because the final presentation is not about the flow analysis. It's about the recommended solution. And your presentation of the potential solutions, really go to that slide. You had one slide that had the potential solutions on there. And here's what I like about this slide. Yeah, you don't need to spend a lot of time talking about all the different potential solutions. So you correctly, no, go back to the slide where you had a potential solution. Yeah, 3 potential solutions. Go back to that slide.
Wait, do you want this one?
Yes, that one.
Okay, sorry.
The one that says potential solutions. So you've got a name for it, and then you've got a bullet that kind of tells a little about it. And Michelle used that to tell the client, to tell us about, so here's what we considered. Don't need to go into too much detail because we're going to talk a lot about the recommended solution. I liked your selection analysis. Go to your next slide. Let's just go through these one at a time here. Okay, got that. Here's the criteria and the scale. Yep. Here's your decision matrix. Instead of solution 1, solution 2, solution 3, I'd like to see the names instead of that. That's just a little bit more, a little clear for me. You guys know them by number, but I don't. Go to your next one. And here's what I really like. By criteria, you explained here's what it took to get a high score, and here's what a low score meant. So that was good. We could talk more about that, like why a low score is only 6 instead of 3 or 2 or 1 or 0. But still, you really did very well there. So I like this selection analysis. It's probably the best I've seen. Let's go to.
Yeah, I agree. This was a very good section of the presentation. And again, the information was all correct. So that was very impressive to me, and in a very clear way, so anyone can see why one solution was better than the other. So anyway, I didn't want to interrupt, but yeah, this was very impressive.
Oh, feel free to interrupt anytime here. Zach, you really carried the load here, I think, with your eye-watering, very detailed description of the recommended solution. Let's go to that. So you had your cool diagram there, and you took each one of those and you stepped through using colors. You know, you have the diagram on the left and the additional information on the right, and you went through each step. Wow, that was really good. I really have a good understanding of what each piece of the equipment is. See, you highlighted the word freeze over on the left. But I agree with Dr. Castell here. Here you've got some numbers. At least I know how long they're frozen for. I think I may have asked you that in a previous presentation. But there's other places where I felt like you could have put some more numbers. Let's go to the next one here. Okay, so yeah. And here's a little just, I'm really nitpicking because that's all I can do is just nitpick because your content is good. So the step over there on the left says remove stems, but the title says destemming. So I would probably, if it was me making the presentation, I'd want more consistency there. But I like the way you've got a picture of the equipment and then some bullets to guide Zach's explanation here. It shakes bushels, leave stems discarded, return to freezer, or continue. Probably a little. You've got room for a little bit more detail. I mean, those are definitely bullets. They may be 22s instead of 357 magnums, if you know what I mean. So I'd probably put a little bit more into that. But I'm just kind of nitpicking. Go to the next one. I'm going to try to highlight areas where I would have probably put some more numbers. Second water bath. Okay, you've got a you know, a tub there. You know, what's the capacity of that? That might be nice. How many berries do you remove at once? But what I really focused in on was the word toxins. And maybe you said it, Zach, but I'm immediately thinking, what toxins are you talking about? More specificity on what specific toxins are there? Can you answer that question? Maybe you covered it.
So I actually failed to mention that in this slide. I say failed to mention. I failed to use the word toxin per se in this slide. But when the berries are not ripe, they have anocyanin, I think is what it's called, which is essentially cyanide. The unripe berries, the stems and the leaves can produce cyanide. So this step, when it says removing toxins, it's removing that as far as so the step before this, removing stems, that's more focused on, you know, getting rid of the stuff that we obviously can't use, right? But this one is specifically geared towards getting rid of berries that might be harmful to people to consume.
Yeah, so I would say here you're removing unripe berries. I'm not quite sure how this works. Do the unripe ones float to the top? I mean,
yes, sir. And I did mention that, but I might have spoken too quickly over it. But since they're being submerged in that basket, Austin talked about this during his risk mitigation. While they're submerged, an employee will disturb and agitate them because the unripe ones actually float. So this ensures that, you know, if there's a pile of berries in there, when you agitate it, it shakes it around, gives the unripe ones a chance to come out from underneath. And once they floated to the surface, they'll use the skimmer on the far right there to scrape them off the top.
okay. I love this discussion because very few projects we get into this level of detail on the content. Usually I'm talking about your picture's too small or your font's too small, all that nonsense. But this is good stuff.
Yeah, I like that. It is the density separations step. I would have liked to know how many berries, you know, per hour do they separate. I have no sense still of the actual flow, right, of materials in this. This is one of the examples. I might use that in 315 next year, where material balance is will help me quantify the process, so you could play with that. But otherwise, excellent.
So unfortunately, with some of these processes, it would be an
hard.
estimation at best to give you how long it would take. I believe y'all are aware that we did try and get a hold of some elderberries, and that was difficult in itself. But for processes like removing the stems and then thawing them,
I'm aware
a
of
lot of
that.
that, a lot of that can depend on the employee itself working the machine. So we chose to leave that out.
That's fine. I'm aware of that, so don't worry.
Yeah, well, and that's a good point. They can roll that into the risk analysis. I know Austin talked about toxins during the risk analysis, and that's really where I kind of picked up on what toxins are we talking about? I don't, okay, so let's move on from this. So really nice job here on the process describing the recommended solution. Yeah, you got some numbers on that slide. So again, I hate to repeat what Dr. Castell said. I'm also interested in the capacity of your system, how much you're going to produce per day. I think your economic analysis is done per day, and we'll get to that. Okay, so let's jump to economic analysis. Immediately, I look at this slide, and I see the font's just a little bit small. I have to make this. I have to give the slide more room and make your faces smaller on my Zoom so I can read it. And so I didn't like to do that because you have such nice handsome faces. But that's okay. Okay, so one comment I had here, Austin, is so let's look through this here. On this slide, you talked about a vacuum distiller. You said the vacuum distiller was the most. Well, I think maybe I heard you wrong. But this is a nomenclature issue here. You talked about the vacuum distiller being the most expensive thing. I'm looking over there. I don't see a vacuum distiller. What are you talking about?
Yes, sir. I realized that as I was presenting, the rotary evaporator is another name for a vacuum distiller.
So nomenclature, consistency is important. Otherwise, you confuse your client and the person giving you the grade, that kind of stuff. So,
Yes,
but I figured it out because you had the number of 4,000. So I said, oh, that must be another name for the vacuum distiller. But I just had to poke you in the eye about that. Take that.
Yes,
Okay.
sir.
So that's a fixed cost. Go to your next slide. Got that. So your previous slide was like your initial investment. Here's your variable costs in labor. These costs are per day and some per hour. So I'm seeing you've got the total operating cost, $19.69, and you've got labor. It looks like $136.50. So this is a day, right?
Yes, sir. And I should have put that on there. The total prices are dollars per day.
Okay. So go to your next slide. So I'm looking for this to eventually turn into per year. This is still a daily total. You're expecting to only get one. No, go back. This still is amazing to me. Only a little more than a gallon a day.
Yes, sir.
Yeah, that's pretty. And then the 22.5 pounds a day of the pulp. But and I'm kind of going back to what Dr. Castell is saying. What was your starting mass? Was it 100 pounds?
Yes, sir. Our the lowest possible amount and what we were told to expect initially was 100 pounds of raw elderberries per day.
Okay. Yeah, so I'm just curious as to what happened to the other 75 pounds of stuff. There weren't that many stems. Anyway.
Many of that weight goes away as water.
Ah, that's right.
So the output, the yield is very low. Yes.
Yeah. So attention to that part of the, how you end up with 1 gallon of concentrate from 100 pounds of raw material. Go to your next slide. So this is still a day total. And here I'm looking at revenue generated, $179 a day. Profit is $25 because that's the difference between operating costs and revenue generated. I'm having to jump, too far in this table to get the $25. I would have put your equipment expenses at the top, then 153, 179. Those would be closer together to show the profit is 25. How did you go from $25 a day profit to an annual profit of 6610. Are you going to make me do the math and figure out how you got that? Tell me.
No, sir. So that's our fixed cost divided by our profit to get how many days it would take, and then from there we turn
Fixed
that to
cost. So 69.91 divided by 25.
Yes, sir.
But are we talking about days or years? Because annual means years. How many days of operation does this have where you're making $25 a day?
Sorry,
That's
the days of operation, I want to say were just over 250, assuming an average work week. One of the things we covered in the previous presentation that was excluded from this one was discussing how we determined what a work week was going to look like in Guatemala, because we're unaware of their cultural and that's what I'm looking for. Holidays. We're unaware of their holiday schedules, so we just went off of a typical American work week, which is basically 5 days a week. So the annual profit is the $25 times, I think it was 254. I have the numbers somewhere, but like I said, it
I
was in
remember
the
that
previous
number now.
presentation.
I remember that. But I've got a bad memory, so that's why it needed to be on this slide somewhere. So, okay, so you did the work, you just didn't demonstrate fully how you did the work. Let's see about my notes here. $57 a gallon. I think Dr. Castell brought that up last time. Wow, that's some pretty.
Yes.
Now I realize you're selling this by the pint or half pint, and it's a concentrate. So, how many? Break that into a unit cost. Let's say if when I go to the grocery store and I buy a can of orange juice concentrate, I might spend $4 or $5 on that, and I think that may be a pint or maybe it's a pound. I don't know. How's this going to be sold?
So,
Packaged.
I believe I might have mentioned this. I might have forgot to mention it in the beginning, but when we're selling the concentrate, we're selling it to be further developed into a supplement product. And so we're not selling directly to consumers, but the client would rather be selling to like a secondary producer, I guess would be the best way to explain it. And so for a gallon of concentrate, that's going to like create a like you're not going to be selling it in that unit to a customer. You're going to be selling it as like a syrup or like a little gummy. And so that unit of that amount of concentrate is going to, I mean, I can't quantify how much that would make in the end product, but I mean, it's going to last quite a while in making that end product.
Right. So how did you come up with $57?
So Zach might be able to better answer this, but we looked at base prices for what it's sold in the U.S., and that was kind of difficult because a lot of when you like look up, elderberry concentrates and elderberry products, you get a lot of like the sambucol liquid for when you're sick and stuff like that, not just like the raw product itself. But we found a price based on different quantities and kind of averaged a few different ones to meet the daily quantity that we were producing. And that was not the first one. We actually, I believe that's halved from our initial price, as well as the berry pulp was also reduced. But again, Zach could probably explain that better.
Yeah, the prices were based off of a combination of market research and then adjusting our economic analysis to see what we can get away with charging while also maintaining above zero profit. So this was kind of the lowest we wanted to go as far as prices are concerned. But again, because the market research is so limited, especially trying to find similar products in America, we had to use our best judgment.
Okay, well, that's a good answer. Given that your payback period is basically a year, that tells me that either this is a really lucrative process, a really lucrative deal, or you're being a little overly optimistic on the price. So I might have given the uncertainty, and this would feed into the risk. And I know you talked about a financial risk. Let's go to that slide then, Austin. So this is a financial risk because your $57 a gallon is not really based on some solid data. So I'd have been more specific about financial risk here. And then there's a phrase we use in the assignment. It's called range of values. So give a low end, here's the lowest we think that it might possibly the revenue might be, and here's the high end. And that way you're presenting that to your client. And then you could actually, to be conservative, base your economic analysis on the lower end. And your payback period might be 36 months instead of 12, but a 3-year payback is not unheard of in the business world. I don't know what their standard was, but anyway, does that make sense to you?
Yes, sir. Absolutely.
Okay, great. Here's the last thing I'm going to say is, one of the things that the fun of these projects is you get to learn about something that you haven't learned about in class. I don't think Dr. Castell covers the properties of elderberries in her class. Maybe she talks about some other things, but not elderberries. But I bet you've seen other similar properties of food products, either in her class or other places. So here's an opportunity for you to translate that into something new. So use your research. I wish I'd have told you this at the beginning of the semester, but find out what some of these properties of elderberries are. What makes them so sought after? Why do people want to buy them instead of something cheaper? Is there a market outside of Guatemala for these? So that would have been a nice little kind of some icing on the cake to give your client is, hey, we've looked up elderberries and man, they cure cancer and they cure coronavirus and they cure all these other things. And they have the right kind of sugar. I don't know all the terms, whatever. They've got omega-3s and all these healthy things. I didn't see anything like that. So that might have been nice earlier on, maybe in the project description. And then you could talk about the bagasse, the residue, that leftover part, about why this is marketable. What makes this marketable? Instead of just, here, you want some leftover elderberry junk? Okay. So
I think they have addressed the benefits of the elderberries since the beginning of the class. It has the anthocyanins, and this is the good compounds that Americans are after. And here you can find the berries as a gum. Don't find the fruits. So they have done a good job, and they did good research on addressing that. The problem is that at the same time that it has the anthocyanins, it can also have the cyanide, and that becomes a toxic problem. But I think they are aware of that, and they have addressed why elderberries are so good. They don't cure COVID yet, but but they have very good nutritional value.